guys, so let's have a look at the possibility of these huge boxes being transported by wooden rollers. You can see wood is a natural material, so trees are not symmetrical, therefore getting circular shape would be it's very hard task, so we want it you can see this is also twisted, and it cannot be used directly for rolling. Here is the ebon wood, very hard, from Africa, so yeah, they could have ebon wood, but here you can see the structure of growth, so you can see it's natural shapes, and it's not geometrical, it's not circular, so you need to use some technique to make it shaped it. So there are different types of how to test the hardness of wood, but we can take this compression perpendicular to grain limit as important for us. It's always lower than compression parallel to grain, because of the trees are growing up and they need to deal with the wind, so this is why, and we will see in our case it will mean like we need 8 rollers, and the pressure on each roller will be 8 ton, and yeah, that will be a pressure of 3.6 kilograms at square millimeter, and we are exceeding the limit, for example, for maximum compression strength for exceptionally strong wood. So the box will crush the roller a little bit, and that's the reason why the coefficient of the friction is gonna be high. It's not gonna be that low as maybe somebody would expect. You see, this is what is going to happen. This is the elastic model. You can see it's like squeezing the roller. Also the same force would be crushing the wood from opposite side. So here we are crushing a little bit the rollers, and you can see 8 rollers would be enough. I mean, we are not gonna crush it, but we are gonna deform it into that way that the coefficient of rolling resistance would be too high to be this a good idea. You can see in a model we'll use something like this. So this is we'll use some polygons. You can see some of them have more sides, and you can see at this case it's almost circle. Okay, so it's like 1 millimeter difference between the circle and between the polygon, and that's the only way how it could work. But so we can use this for as a model. This guy this year in 2015 he published his theory, and it's about it's very practical actually. Is about that you can make a polygon from some count of sides, and you can get rolling friction, coefficient of rolling resistance from this. It's because it's like moving up and down if it's shaped into polygon, and there is some energy that needs to be done. Okay, so it's very simple and very useful. And this is something that we can calculate with, and you can visualize for yourself if it's possible. Okay, so this is like 15 sides, I think, but it wouldn't be possible. The coefficient of friction would be very high if it would be shaped like this, and it needs to be this shape through all the length of the roller. So imagine this when you are considering this. So if you have shape of a roller that will be made from a polygon of 100 sides, you will have coefficient of friction 0.008. Okay, and it can be transported by a couple of people, like maybe like 10 people. But it's not real, because ancient Egyptians didn't have these tools. Just compare it to coefficient of rolling resistance of, for example, ordinary car, tires on concrete, stagecoach from 19th century, large truck tires. So you see that they would need, if the coefficient of rolling friction is 0.08, they would need 150 people. So and they just couldn't make it on a millimeter precision. So just make the decision for yourself. Use Google, and you will see why it's not possible. Okay. So and next time I heard some story about air in bags lifting the stones. So